Before we start today's episode, I've got a number that you can call or text with questions and comments. Hit me up at 720-772-7988 and leave me a message. I'll be sure to get back to you.
All right, lift off and the clock has started.
We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
Listen, Tranquility Base here. The Eagle has landed.
Discovery, go at throttle up.
And liftoff, the final liftoff of Atlantis on the shoulders of the space shuttle. America will continue the dream.
This is The Space Shot, episode 407, This Week in Space History from January 6th to the 19th. I'm John Molnix. This week is a double-header episode, just because I've had some stuff going on in my personal life, with family and friends of family being in and out of the hospital. It's been kind of crappy last few weeks, but we're getting back into the swing of things. Let's start off today with some prospecting. On January 6th, 1988, NASA's Lunar Prospector mission lifted off. Its destination was our moon. This spacecraft was designed to operate in a low orbit around our moon, mapping the composition of the lunar surface, measuring gravity, and magnetic fields of our closest neighbor. Interestingly, it also looked for polar ice deposits and lunar outgassing. We'll be talking more about the ice and outgassing in just a bit. Lunar Prospector was spin-stabilized, and I know I've talked about this before, but for those of you that are new to the podcast, let's chat about it a bit. You can think of a football, and for my listeners outside of the United States, I'm talking about an American football. When a quarterback throws a ball, they impart spin on the football to keep it stable and give it a more accurate flight path. The same goes for spacecraft. Spin stabilization means that the spacecraft doesn't have to expend fuel just to keep it oriented in the right way. This allows for a longer service life since less fuel is needed, and it also enables a lighter spacecraft which can pack more science instruments on board. The spacecraft also carried an alpha particle spectrometer that was designed to detect radon outgassing that is related to the tenuous lunar atmosphere. The primary mission of Lunar Prospector was to map the entire surface of the moon from about 60 miles up. As part of the extended mission, the spacecraft lowered its orbit to as low as 6 miles above the surface of the moon. This close proximity allowed scientists to make measurements at resolutions that were extremely precise. After completing its primary and extended missions, this golf cart-sized spacecraft slammed into a dark region of the Shoemaker crater near the moon's south pole. It was hoped that the impact of the spacecraft into the lunar surface would release material that would be visible from Earth, but sadly nothing was observed on impact. On January 9th, 1990, the Space Shuttle Columbia lifted off on a nearly 11-day-long mission. Columbia and her crew deployed a SYNCOM satellite and brought back an extremely interesting satellite. Originally launched in 1984 on the Space Shuttle Challenger, LDEF, or the Long Duration Exposure Facility, was meant to stay in orbit originally for just 1 year. The Challenger disaster and other delays caused LDEF to be left in space for much longer than initially planned, about 5.5 years. According to NASA, there were 57 science and technology experiments carried on LDEF, and, quote, those experiments represented the work of more than 200 investigators, 33 private companies, 21 universities, 7 NASA centers, 9 Department of Defense laboratories, and 8 foreign countries. LDEF appeared in the movie The Dream is Alive, which I first saw in an IMAX theater. My parents got me a copy of the movie on VHS, and I ended up wearing out that cassette after rewatching the movie so many times. I've always been fascinated by the design of this spacecraft, even though it's incredibly simple. It was a 12-sided structure plus 2 ends that measured about 30 feet long and 14 feet wide. LDEF weighed about 21,000 pounds at launch. There were different panels, each with different materials and experiments that were exposed to the vacuum of space over that 5.5 years. The materials and experiments carried on LDEF helped inform the design of the International Space Station and other spacecraft that will be in orbit for extended periods of time. The longer-than-planned mission also presented NASA with an opportunity to use LDEF as a, quote, meteoroid and orbital debris detector. On January 11, 1996, the Space Shuttle Endeavour lifted off from Launch Complex 39B on a nearly 9-day-long mission to retrieve a Japanese experiment that had launched 10 months earlier on an H-2 rocket. The Japanese Space Flyer Unit, or SFU, carried different experiments ranging from biological studies to materials science. The crew of STS-72 captured the spacecraft on the third day of the mission, and with that objective completed, the crew began working on 2 EVAs. In addition to capturing the Japanese SFU, the crew of STS-72 also deployed the Office of Aeronautics and Space Technology Flyer, or OST Flyer. Too bad they didn't include a T in front of that name. It would have been funny because they could have deployed and captured toast during their mission. Endeavour touched down at the shuttle landing facility in Florida during the early morning of January 20th. The NASA mission page for STS-72 notes that sonic booms were heard at 2:39 a.m. Eastern Standard Time, and the astronauts mention how they probably woke a few people up. I've got a fun piece of pop culture history for today. If you're a fan of Star Trek, you probably remember the SS Botany Bay. While there's no official canon launch date, a Star Trek story lists the launch date for the Botany Bay as January 11th, 1996. Thankfully, Khan and his group of augments didn't launch from Earth on a sleeper ship 22 years ago today. On the off chance, if you haven't seen the original Star Trek episode Space Seed, definitely check it out on Amazon Prime or Netflix or wherever you watch your streaming videos. We've got a lot of shuttle history for this episode. On January 12, 1986, the Space Shuttle Columbia lifted off from Launch Complex 39A on the second night launch of the shuttle program. This was the first flight for then astronaut Charles or Charlie Bolden, who went on to become NASA's administrator from 2009 to 2017. Also on this flight was then Congressman Bill Nelson of Florida. Nelson was also a senator from the state of Florida, and he served on various space committees over his years of service. Nelson became the second member of Congress to fly into space after Senator Jake Garn on STS-51D in 1985. Columbia deployed a communications satellite and conducted numerous science experiments. On a sad note, this was the last successful mission before the Challenger disaster. Let's fast forward about 2 decades. The next mission to launch on January 12th was STS-81, which was a shuttle Mir mission in 1997. STS-81 was another night launch, which are always the prettiest in my book, and Atlantis spent 10 days in space, nearly 5 of which were docked with the Russian space station Mir. Now let's change gears to a robotic mission. NASA's Deep Impact mission launched on January 12, 2005. Its destination was Comet Tempel 1. As its name implies, this mission was unique because an impactor was released from Deep Impact. This impactor struck Comet Tempel 1 on July 4, 2005, producing a massive flash that was observed by the spacecraft. Let's continue with our shuttle-centric episode this week. The Space Shuttle Endeavour launched on January 13, 1993, on a mission to deploy a TDRS, or Tracking and Data Relay Satellite, into orbit. STS-54 was nearly 6 days long, and now we're going to switch it up a bit to talk about black holes. There are different sizes of black holes, ranging from the smallest, which are stellar black holes, and they have a mass between 5 and 100 times that of our Sun. There's also larger, mid-mass types that have been more recently discovered, and finally, supermassive black holes that have masses millions of times that of our Sun. According to NASA, quote, "When a star runs out of nuclear fuel, it will collapse. If the core or central region of the star has a mass that is greater than 3 suns, no known nuclear forces can prevent the core from forming a deep gravitational warp in space called a black hole." A black hole does not have a surface in the usual sense of the word. There's simply a region or boundary in space around a black hole beyond which we can't see. This boundary is called the event horizon. The radius of the event horizon, proportional to the mass, is very small, only around 30 kilometers for a non-spinning black hole with the mass of 10 suns. Anything that passes beyond the event horizon is doomed to be crushed as it descends ever deeper into the gravitational well of the black hole. No visible light, nor X-rays, nor any other form of electromagnetic radiation, nor any particle, no matter how energetic, can escape. I don't know about you, but being doomed to be crushed as you descend ever deeper into a black hole doesn't sound like a good time to me. I'll be linking to some NASA resources on black holes in the show notes. Check it out, it is a fascinating topic. The reason I mention this today is on January 13th, 1997, NASA announced that 3 black holes were discovered in 3, quote, normal galaxies, which suggested to astronomers at the time that nearly all galaxies can harbor supermassive black holes. Now let's talk about something a little less dangerous and head to Titan. On January 14th, 2005, the Huygens lander touched down on the surface of Titan, giving us an unprecedented look at this captivating moon. This was the first and so far only time that a spacecraft has touched down on another world in the outer solar system. Even though the Huygens part of the mission was just a brief part of the overall Cassini mission, it marked an incredible milestone in the exploration of the outer solar system. I remember talking about the landing in my high school astronomy class and being in awe of the video of the landing sequence that was put together with pictures captured during descent. I'm linking to that video in the show notes, so be sure to give it a watch. Titan is a massive moon. It's larger than Mercury and is the second largest moon in our solar system. According to NASA, quote, Titan is the only moon in our solar system that has clouds and a dense atmosphere, mostly nitrogen and methane. It is also the only other place in the solar system to have an Earth-like cycle of liquids flowing across its surface. Much of what we now know about Titan is thanks to the Cassini and Huygens spacecraft. Huygens performed a 2.5-hour descent through Titan's atmosphere, during which it experienced winds in excess of 260 miles per hour. The Huygens lander gave us the first images of Titan's surface as it passed through these dense upper clouds. Spacecraft aren't able to see through this dense layer of Titan's atmosphere, so having the Huygens lander was an essential part of giving us a look at the surface of this enigmatic moon. The lander was traveling at just over 11 miles an hour when it touched down on a freezing plain littered with what looks like icy tumbled stones. Speaking of the surface of the moon, the temperature on Titan is frigid. It's in the neighborhood of negative 290 degrees or negative 179 Celsius. Huygens was able to image its entire descent, and during this time it also gathered information on the atmosphere of Titan. It found complex organic compounds, which are the building blocks of amino acids, which are necessary for life as we know it. The Huygens lander was developed by the European Space Agency. While the scientific knowledge we gained from the lander is incredible, I think that the international collaboration and cooperation needed to pull off this interplanetary landing is just as important. It echoes something that President Kennedy said during a speech at Rice University. There's no strife, no prejudice, no national conflict in outer space as yet. Its hazards are hostile to us all. Its conquest deserves the best of all mankind, and its opportunity for peaceful cooperation may never come again. The Cassini-Huygens mission represents the best of what we can achieve, peaceful cooperation between sovereign nations working towards a common goal of expanding scientific knowledge. As much as the science will be part of Cassini's legacy, the partnership between nations for this mission will be just as important 50 or 100 years from now. Now, let's take a ride on a roller coaster. On January 15, 1975, Space Mountain opened in Tomorrowland, which is part of the Magic Kingdom, at Disney World in Florida. This roller coaster has a retro space theme and is almost entirely in the dark. I remember riding it as a kid when we were at Disney World, but it's been ages since I've been. On January 15th, 2006, a sample return capsule that had been jettisoned from the Stardust probe entered Earth's atmosphere, landing just outside of Salt Lake City, Utah. Stardust was a NASA Discovery-class mission that encountered the comet Wilt 2. The Stardust spacecraft collected samples from the comet and interstellar dust for return and analysis on Earth. The samples from the comet and interstellar dust were embedded in an array of aerogel cubes. The sample return part of the Stardust mission was the first time that any particles from a comet were returned to Earth. This unique aerogel collector was moved into position when the spacecraft moved behind the comet Wilt 2. The aerogel acted as kind of a ballistics gel, which allowed the dust to impact into something that wouldn't completely destroy it. After the Stardust probe had captured the cometary and interstellar particles, it conducted a series of flybys of the comet Wilt 2 and Tempel 1. These flybys captured high-resolution images of both comets, and in the case of Tempel 1, provided another set of images that complemented the earlier Deep Impact mission. Stardust's sample return capsule provided valuable information about the composition of the comet and interstellar dust. The particles embedded in the aerogel ranged from microscopic to almost 1 millimeter in diameter. A variety of particles were collected, from organic compounds to crystalline silicates, and most interestingly, glycine. Glycine is an amino acid, and its detection on a comet, quote, supports the idea that the fundamental building blocks of life are prevalent in space, and strengthens the argument that life in the universe may be common rather than rare, according to Dr. Carl Pilcher, former director of the NASA Astrobiology Institute. Discovery-class missions like Stardust have provided NASA with a cost-capped way to expand our knowledge of the solar system. It's wonderful to see that these relatively inexpensive missions can produce so much incredible science. Now we've got a sadder piece of history. At 10:39 a.m. Eastern Daylight Time on January 16, 2003, the Space Shuttle Columbia and a crew of 7 astronauts lifted off under a picturesque Florida sky. Commander Rick Husband, pilot William McCool, payload commander Michael Anderson, mission specialists Kaplana Chawla, David Brown, Laurel Clark, and payload specialist Ilian Ramon. This was the last time that Columbia would leave Earth. 4 years ago today, on January 17, 2016, SpaceX launched the Jason 3 satellite, which is a joint U.S. and European series of satellites that measure the height of the ocean surface around Earth. Jason 3 carries numerous instruments, the prime one being a radar altimeter that measures sea levels, wave heights, and wind speeds. Studying Earth's oceans is important because it allows scientists to gather data on seasonal and decadal variability in sea levels. The more data that's collected, the greater the understanding of how our oceans change over time. Jason 3 also gathers data that helps create more accurate surface wave forecasts and more accurate forecasts of the intensity of hurricanes. The operational lifetime for Jason 3 is 3 years, with the possibility of extending the mission for another 2, allowing for even more data to be captured. As of 2020, the spacecraft is still gathering data. Satellites like Jason 3 are important because they expand our ability to accurately forecast ocean conditions while also supporting commercial applications that rely on sea travel. The satellite is used in, quote, weather modeling for seasonal forecasts, tropical storm intensification forecasts, and coastal forecasts. It will also be applied to fisheries management, marine industries, and research into human impacts on the world's oceans. The Jason 3 spacecraft launched on a SpaceX Falcon 9 rocket. The landing of the Falcon 9 rocket on the autonomous drone ship, Of Course I Still Love You, didn't exactly go as planned. It's not the picture-perfect landing we've come to expect from SpaceX. According to a tweet from Elon Musk after the landing, the Falcon 9's landing leg lockout didn't latch, which caused the rocket booster to tip over on that faulty leg. A successful landing on a drone ship had eluded SpaceX up to this point, but success wasn't too far off in the future for the company. In April of 2016, they stuck the first landing on a drone ship during the CRS-8 launch for NASA. On January 18, 1974, the British military satellite Skynet 2A launched from Cape Canaveral.
The Skynet funding bill is passed. The system goes online on August 4, 1997. Human decisions are removed from strategic defense. Skynet begins to learn at a geometric rate. It becomes self-aware at 2:14 a.m. Eastern Time, August 29th. In a panic, they try to pull the plug.
Skynet fights back.
Yes, it launches its missiles against the targets in Russia.
Why attack Russia? Aren't they our friends now?
Because Skynet knows that the Russian counterattack will eliminate its enemies over here.
Jesus.
Don't worry, this satellite wasn't part of Skynet, the fictional evil AI system that nearly wipes out humanity in the Terminator movies. The real-life Skynet 2A didn't reach a stable orbit and burned up just a few days after launch. Two more things for today. On January 19, 1965, the uncrewed Gemini 2 test mission lifted off on a suborbital test flight to examine the spacecraft's re-entry capabilities. After months of delays that included an instance where the rocket had to be dismantled due to threats from hurricanes, liftoff of the Gemini spacecraft took place just after 9 a.m. Eastern Standard Time. Onboard computers automatically controlled the Gemini spacecraft and initiated the retrofire sequence that brought the capsule back to Earth. Gemini 2 splashed down just 18 minutes and 16 seconds after launch, successfully completing its mission, even though there were some issues with systems on board the spacecraft. The uncrewed Gemini test flights paved the way for the first human Gemini mission in late March of 1965. Lastly for today, let's head to Pluto. The New Horizons spacecraft launched on January 19, 2006. Its destination, Pluto and beyond into the Kuiper Belt. At launch, New Horizons was moving incredibly fast, just over 36,000 miles per hour. It was moving so fast that the trip to the orbit of the Moon took about 8.5 hours. After a gravity assist at Jupiter in 2007, New Horizons entered the extended cruise portion of its mission. Almost a decade passed from launch to Pluto flyby. During the flyby of Pluto, New Horizons went radio silent so its instruments could be pointed at Pluto for the duration of this all-too-brief encounter. The pictures that the spacecraft sent back to Earth are staggeringly beautiful. Be sure to check those out in the show notes. I do have a call-in number if you'd like to ask a question or leave a comment. Just dial 720-772-7988 and leave a message. I'm looking forward to sharing the questions that you may have with all of the listeners. As always, the links to everything we talked about today are in the show notes. If you're new to the podcast, I'd appreciate it if you could subscribe and leave a review. Reviews in Apple Podcasts help more people find out about the show, and they help make sure it reaches as many people as possible. Until next time, I'm John Molnix, and I'll catch you on the flip side.